Hello again, students, and I wanted to go over the practice problems, the chemistry practice problems from week one that have to do with heat and heat systems, like things interacting with environment. And before I do that, however, I'd like to go over a simple, uh, model to keep in mind that I hope you're familiar with: a thermos, brand name bottle holding usually hot objects, hot liquids, and the molecules in there bouncing around, having lots of energy, evident by their motion. So temperature, of course, being an average kinetic energy. So the higher the temperature, the more they're going to be moving around, and they're bouncing into the container walls, which are insulated, meaning that while they bounce off, they don't transfer too much of their energy to the outside. So that is, they bounce off almost perfectly so that they keep their energy. Obviously, it's not perfect, and eventually the material inside, the hot cocoa, will cool off over time, but because it's insulated, it takes a long time for that to happen. So the energy bouncing around, having high temperature, high energy, will eventually cool, with the outside being cooler. So the transfer of energy here is distinctly going from hot to cold, and that would be what we call exothermic. Tried to explain that here with they are bouncing around, and this is a closed system, meaning the molecules themselves, the hot cocoa, is not leaving the thermos. It's just the energy that would be allowed to transfer. That leaving is what we call exothermic, and that will continue until the outside and inside temperatures are the same temperature. We call that thermal equilibrium, fancy word for it. But this is an exothermic process, but it's a closed system. So I just want to keep that in mind as we think about the answers here, that when you're touching a cold ice cube, your hand gets colder because heat is leaving. They say travels from hot to cold, so that would be a transport of your hot hand to the ice. Warm cup of coffee, take away from, I emphasize from, that seems like it's going away. That would be false because it's actually the other way around. The hot cocoa would be giving you heat. Hat keeps you warm, traps the heat. That's a little simple because think of the hat as sort of like an insulator as well. So it's sort of trying to close off the heat transfer from your head. So that's why we say true. We already mentioned the thermos is a closed system because it's sealed off, but a open pot of spaghetti, lots of starch in that water, is open because there's no lid keeping in the heat. And also, by the way, it's allowed to evaporate. That's important. The water vapor is leaving it. A greenhouse would be considered closed because it's not allowing anything, no air, no water vapor to leave. Only energy can come in or out. Although one could argue maybe water is being piped in somehow, and that could be considered open. So yeah, I say closed because we think of it as only energy coming in and out. But if you think about it, yeah, they're bringing fertilizer, bringing things in, so that could be open. Water lid, we think of it as closed, typically because the lid is keeping all the vapor inside. But you might say, well, sometimes it spills out, it bubbles over. In that case, it'd be open. A closed cap, meaning you can shake it up all you want, but all the material will stay inside. That's considered closed. And then an open glass of lemonade is evaporating, and so on. Even if it's cold, it's not It's not open. It's open. And same thing with this wonderful, I wish it was vegan beef, but no, is open as well as an apple orchard. Material can come in and out. And I believe, oceans are also open. Aquariums are open usually. They don't seal them off. So there's an exchange of water, vapor, things like that. Pizza delivery bag, think of it as closed, although you might say, well, doesn't it allow some flow of, you can smell the pizza? Well, yeah, I guess so. So that could be considered open. And then this sealed off lettuce would be considered closed because it's not allowing any gases to come off. So while I'm giving you these answers, there is some wiggle room if you think about it a little deeper, but I tried to keep it simple in regarding to what we have here. So hope this helps. If you have other questions or this is still causing confusion, please reach out and don't hesitate to ask. Thank you.